This was first analyzed way back in 1979, before you were born, okay, at the University of Nebraska. And since then, martial arts, there's been a lot of studies. And probably the coolest, most recent one was that little Fight Science video clip that I'll show you guys again later on, where they use high-speed motion cameras and high-tech sensors to get real-time data on those two crazy American brothers who keep setting world records. They're just nuts. I feel bad for their mom, okay? They must have grown up breaking everything in the house. But here's what we know, okay? On average, a 1-inch pine board takes about 856 newtons to break there, okay? The trick is you can break the board if you can generate enough what? Enough force, okay? So we're going to solve for this in a second as a simple impulse momentum calculation. On average, the mass of the human hand is about half a kilogram. Ideally, we should actually try to mass each person's hand, but it's kind of hard. We've actually tried this in the past, to put your hand on a scale and relax. People either end up pushing too hard or they relax too much. The average velocity change is about 6 meters per second. Why negative? When you bring your hand down, right, it has a positive velocity going down, and then your hand does what when it hits the board? Speeds up or slows down when you hit the board? It's going to slow down there, right? So on average, most people can strike at about 6 meters per second. If you've had martial arts training, you probably can strike faster, but we're just going to go with about 6, okay? And then this was a thing that was impossible to measure before. On Monday, we're going to try a new video analysis lab to see if you guys can actually figure this out using Tracker. You'll pick one of the student clips there to look at the impulse force there. But on average, the time of impact for most people with no training, it's about 2.3. What does the M stand for? Do you guys know? Not meters per second. That would be M/S. M is a metric prefix for milli. Okay? So it's 2.3 thousandths of a second. Kind of like a centimeter is a hundredth of a meter. A millimeter is a thousandth of a meter. Okay? So what we're going to do now is we're going to break it down. Let's do our 4 steps here. So in order to break a board successfully, the simplest technique is called the hammer fist strike, where you could do like a knife edge, but if you just make a fist, you're less likely to panic and mess up there. Okay? So here we're going to get a volunteer in a second to make a big fist. And you want to hit with the fleshy part of your hand, okay? Yeah, I'm not a great artist. That's okay. And the idea is you want a little momentum or a lot of momentum. What do you think? You want to generate a ton of momentum, a ton of P. P is for momentum, okay? It's a vector. And when you hit the board, bam, it's Newton's third law, right? That if you strike the board, what does the board do in return to you? The board's going to push back, okay? So your hand is going to end up slowing down to 0 eventually after the collision because your momentum goes to the board there. And the trick is you want to have enough momentum to actually break the board there, okay? So in this case, the picture doesn't help us that much, but that's okay. We want to keep that 4-step process there. Later on, we look at collisions. Picture's super important, okay? And the big idea, it's pretty simple. It's just the momentum in any system before is equal to the momentum after the collision in any system. That's the trick, okay? Kind of like we did energy, initial, energy, final. Some of the forces in X and Y add up to 0, torques clockwise, torques counterclockwise. The trick is it's going to be P before equals P after. Anyhow, next, step 2. Let's break down all of our knowns and unknowns, okay? And a lot of times, people skip this second step, which is silly, because this is the most important step, and that is breaking down what the problem is about. Okay, so the first thing that was given was the average force to destroy a board is around, let me pull that up again, 856 newtons. Okay, so 1-inch pine board, it's about 856 newtons to destroy it. Our trick is to figure out, can the average person with no martial arts training generate enough force to destroy that board there? Okay, so as long as the force of the hand is greater than the force of the board, we're okay. Next, the mass of the average human hand is about half a kilogram. That's just based on human anatomy and looking at statistical averages. Of course, that'll vary. Some people's hands are a little bit bigger and more massive. Some are smaller. No big deal. The average velocity change looks like it was about 6 meters per second? Negative just meaning that it'll slow down to 6 meters per second after you hit your top speed, and then you strike the board there. And then finally, the time, okay? And before, this data we could not collect. We're going to try it later on in the week, okay? And that's 2.3 ms. What's M for? Milli, okay? This is the metric prefix milli, which is 10 to the negative third, or thousandths, okay? So really quick, you should always convert to standard units. How do we convert milliseconds to seconds? We just divide by what? 1,000. So this is 0.0, tens, hundreds, thousands, okay? 0.0023. Move the decimal place over 3 places, okay? So in other words, when you hit a board, it's a little bit over 2,000ths of a second, okay? Now this is a pretty trivial problem. It's not too bad. Momentum, P, is equal to mass times velocity, but we're not really finding the momentum. We're trying to find the change in momentum, okay? Our change in momentum. And that is caused by a impulse force, or impulse rather. Force times time, Newton seconds, is equal to m delta v, kilograms meters per second. Okay? So in other words, we can find the force of the hand because we know the time of impact is 0.0023 seconds, and that's equal to the mass of 0.5 kilograms times -6 meters per second. So let's go ahead and get out our calculators now and plug and chug. I'll race you. You'll win because I got to boot my calculator. There we go. So if I take 0.5 times -6, and then to solve, okay, it's going to be a momentum change of -3 kilograms meters per second. I divide that by the left-hand side of 0.0023. Looks like we're getting a force of -1304. Okay, we'll round that off. F, the force of your hand, and the negative just means that it's a force in the downwards direction, and it's slowing down your hand there when the board reacts in the upwards direction. Okay, really, it's all we care about is the magnitude in the end. Okay, so really quick then, if the average force to break a pine board is 856, is this a pretty safe bet on average? Yeah, totally, right? You don't need any martial arts training whatsoever. Okay, so in a second, I'm going to get a couple volunteers, a couple tips. When you hit the board, okay, think about it. Do you want to strike it towards the edge or right in the middle? What would be smarter? Yeah, in the middle, because if you hit it towards the edge, there's also torque coming into play. You have a smaller lever arm distance. Also, you might hit the chair, which would be bad. You'd like break your hand there, okay? Next, you don't want to use the bone part of your hand, the bony part. You might hurt your wrist bone. You want to use the fleshy part there. Finally, you don't want to chicken out, okay? So what's actually really helpful, it's been scientifically proven, is if you use a nice karate yelp, oi, you'll have better luck there. Hui! Nice big strike there. Woo! Got it? Nice sharp strike there. And you want to follow through all the way there. Now technically, if you're a martial arts expert and you have a lot of training, it's actually better to not just follow through, but to actually bounce. And the reason why, if you think about it, if you bounce, do you have less momentum change or more momentum change? You have more. Theoretically, you'd have double the momentum change. Therefore, double the impulse, double the force there. But that's a hard technique, and people chicken out, and then they hurt their hand there. So follow through. You guys ready? Let's do it.